After months of leaks, teases, and carefully managed silence, Tesla Optimus Gen 3 is no longer a rumor. Images have surfaced showing it standing in a crowd alongside earlier units, and the difference is immediately, unmistakably clear. Elon Musk promised it would look like a human in a robot suit. He called it sublime on the Q3 2025 earnings call. Looking at what is now in front of us, that description lands with considerably more weight than it did when he first said it. The contrast between Gen 2.5 and Gen 3 starts the moment you look at the outer shell. Gen 2.5 wears its engineering visibly: a glossy gold brushed metal body, exposed shoulder joints, visible seams, a head with a bright white LED strip framing the face visor and internal structures partially showing through. It looks powerful, it looks technical, and it looks exactly like a prototype that was never meant to live in a home or interact closely with people for extended periods. Optimus Gen 3 takes the opposite approach entirely. A seamless, all-black outer shell covers the body from head to toe like a full bodysuit, concealing every joint, every actuator, every mechanical component. The shoulders are rounder, the hips more natural, the overall posture less aggressive and more human. Christmas sweaters on Tesla employees in the crowd image suggest the photo was taken in December, consistent with Musk confirming in September that the Gen 3 design was already finalized. This shift matters for reasons that go beyond aesthetics. Elon Musk said it on an earnings call. Optimus 2 was almost impossible to manufacture. That is not a casual remark. It is an admission that however impressive Gen 2.5 looked in demonstrations, it was fundamentally incompatible with the cost targets and production volumes Tesla is chasing. Gen 3's seamless enclosure is not a styling decision. It is an engineering decision that makes every unit cheaper, faster, and more consistent to produce at scale. It moves Optimus from prototype philosophy to product philosophy. Those are genuinely different categories. The most discussed detail from the reveal is not the body, it is the hands. When images of the Gen 3 hands circulated online, the reaction was nearly universal. It looks exactly like a human hand wearing a glove. The proportions of the fingers, the joint layout, the shape and depth of the palm, none of it reads mechanical in the way previous generations did. If Gen 2 hands were capable industrial grippers, Gen 3 hands are closer to the hands of a surgeon or musician, flexible, precise, and built for expressive, delicate work requiring sensitivity and control simultaneously. The confirmed specification is 22 degrees of freedom, powered by 50 actuators with 25 per forearm and hand assembly, using a tendon-driven design that moves actuators away from the fingers into the forearm, exactly how human tendons function. This is a 4.5 times increase over Gen 2 and the most significant hardware leap in Optimus history. Degrees of freedom are best understood as a vocabulary of movement. Each one is an independent direction a joint can travel. Gen 1 had roughly 4 to 5, enough for basic gripping. Gen 2 reached 11, a real improvement but still limiting for tasks requiring finger independence. At 22, Gen 3 can thread a needle, peel a raw egg without breaking the shell, adjust grip dynamically based on weight and surface texture, and interact with the irregular, fragile objects that define any real environment. The robot hands are no longer the program bottleneck, a statement that would have been impossible to make 2 years ago. The intelligence running those hands was not built from scratch for robotics. The AI-5 chip powering Gen 3 shares its foundational architecture with Tesla full self-driving, confirmed at the Terafab event. Optimus does not follow rigid scripts. It operates on an end-to-end neural network that learns by observing humans through video, the same methodology FSD uses to build driving understanding from real-world data. The Grok large language model from XAI handles reasoning and conversation, enabling natural language interaction and autonomous decision-making in dynamic environments. At the Abundance Summit in March 2026, Musk confirmed Gen 3 production begins at low volume in summer 2026, with high volume ramp in 2027 and public consumer availability targeted by end of 2027. The battery represents another meaningful upgrade. Gen 3 reportedly uses NMC chemistry in partnership with LG Energy Solution, a deliberate step up from LFP that prioritizes energy density per kilogram. In a humanoid robot, every extra gram of battery mass requires additional energy simply to carry during movement, creating a compounding efficiency problem that grows with every task. NMC chemistry breaks that loop. The Gen 3 pack carries approximately 3 kilowatt-hours, up from 2.3 kilowatt-hours in the previous generation, supporting roughly 7 hours of continuous operation. The longer-term ambition is a robot running 24 continuous hours in factory environments, and that goal shapes every energy architecture decision across the platform. The supply chain story cannot be separated from geopolitics. Around 50 to 63% of Gen 3 components come from Chinese suppliers, driven by economics. Morgan Stanley analysts estimate a fully US-built Optimus would cost approximately $131,000 per unit. Tesla long-term price target is below $20,000 at scale. Closing that gap requires China precision manufacturing depth that currently has no equivalent elsewhere. The Fremont factory lines that previously built Model S and Model X have been converted to Optimus production. A dedicated facility at Gigafactory, Texas, is under construction, targeting a long-term capacity of 10 million units annually. As of March 31, 2026, Musk confirmed on X that Optimus 3 is mobile and walking, but needs finishing touches before the official reveal. The robot has been observed serving at the Tesla Diner in Los Angeles and was showcased live at the Appliance and Electronics World Expo in Shanghai. This is not a controlled demo anymore. It is a deployment-ready platform being tested in real environments. The official reveal, delayed from the Q1 2026 target, is expected within weeks, with the June shareholder meeting the most widely anticipated stage. The comparison Musk made on X is worth sitting with. He put Optimus Gen 3 in the same category as Raptor 3, SpaceX's latest generation rocket engine, one of the most advanced pieces of engineering alive. He almost never makes that comparison. When he does, it signals a genuine step change. Whether that holds under mass production pressure and safety validation is the defining question of the next 18 months. But looking at the hands, the AI-5 chip, the tendon-driven dexterity, the converted factory lines, and the Giga Texas facility rising to produce 10 million units annually, the foundation is more solid than ever. The robot that once looked like an engineering exercise is starting to look like a product. For anyone watching this industry, that changes everything.